some important points related to velocity. Okay, some important points of velocity. So first of all, SI unit of velocity. Okay, then we know that the formula of velocity is displacement upon time, and displacement is measured in meter and time is measured in second. So meter per second is the SI unit of velocity. Second point is CGS unit of velocity. Okay, CGS unit. Then we know that in CGS units displacement is measured in centimeter and time is measured in second. So centimeter per second becomes the CGS unit of velocity. And third one is some other unit of velocity. Then some other unit. Okay, then displacement, we know that displacement also is kilometer. Okay, so you can say that kilometer is okay, and time is other unit is time, except second is minute, hour, so its unit becomes kilometer per hour, or you can write here as kilometer per hour or kilometer per minute. Okay, kilometer per minute, you can write it as kilometer per minute. Okay, so in this way this is some unit of velocity. Okay, next point is velocity is a vector quantity. It means it has magnitude as well as it has direction of motion. So it has direction of motion. For example, 5 kilometer per hour along 5 kilometer per hour towards east. Okay, then this shows that's the magnitude and east shows that direction. Okay, towards east. Okay, next point is velocity can be positive, negative or zero. If you says that then velocity is equal to displacement upon time, then we know that displacement may be positive, negative or zero. Similarly, in this way, if displacement positive, then velocity is also positive. If displacement is negative, then velocity is also negative, and displacement is zero, then velocity is also zero. Okay, so you can say that velocity may be positive, negative or zero. If you want one example, then take an example of positive velocity. Okay, positive velocity. Suppose it's this is the position is A, this is B, this position is C. Okay, a person start his walk from A and cover 3-meter distance, 3-meter distance, okay, along east, and again 200-meter distance along B to C, okay, along a straight line. Okay, the motion is along straight line. There is a road, straight road, and a person is cover 3-meter distance from A to B, then it covers B to C, okay, B to C 200-meter, okay. Suppose the time is taken by the person is 20 meter, and this cover in 20 seconds, and this is cover in 30 seconds. Okay, I'm saying about it's maybe different, has different speeds. Okay, it has different speed. Okay, it take 20 seconds, and to cover 200 its speed is slow, so it takes 30 seconds. Okay, now here the speed is fast. Okay, here is moving with, here he is fast and here is slow. Okay, now calculate the displacement from A to C. Then its displacement is AB plus BC, okay, shortest path, because path is same, and distance is also, because this is shortest path, because this road this has straight road, so you take AB plus BC. AB is 300 meter along east, plus BC is also BC is also 200 meter, then its value is 500 meter. Okay, its value is 500 meter. How much time it takes? It takes total along, okay, show the direction along AC, okay, along AC. Now the time is 20, how much total time? Total time is from A to B is 20 seconds, and from B to C is 30 seconds, then total time is 50 seconds. Okay, 50 seconds. So calculate the velocity. So calculate velocity. Velocity is equal to displacement, which is 500 meter, okay, which is 500 meter, and time is 50 seconds. Time is 50 seconds. Then what is the velocity? Velocity is 250 25, sorry, cancel it, then you get 10 meter per second, then you get 10 meter per second. Okay, and because his first start his journey in this directions, okay, and direction, so you take its 10 meter per second along A to C, or you can write also as plus 10 meter per second, plus 10 meter per second, because when you draw coordinates x-axis, then this direction so positive. Okay, this is the positive x-axis direction, and if a body moves in opposite, then it is negative. Okay, because I take first is it is in this direction, motion is in this direction, so I take it as positive. It's moving along positive x-axis, so you can take it as, it means it moves towards positive x-axis, positive side. Okay, and similarly case negative, when it becomes negative, okay, when it becomes negative, then take again this example as, okay, suppose a person moves along a straight line, cover 300 meter distance, and after crossing B it reached at point C, then it turned back. Okay, then it turned back and cover it, and it reached at point D by the same path, following the same path, and reached at point D, which is 7 meter, which is 700 meter from C. Okay, from C. Okay, then question is that what is its displacement? okay, and it takes 50 seconds. Suppose it takes 50 seconds to turn, okay, to move from C to D. Okay, then question is that what is displacement? Then you know that displacement, positive direction is, displacement is AB plus BC, both are in the same direction, plus C to D, C to D, this is also add, total displacement is this, but AB is in along positive x-axis direction, so take positive 300 meter, positive 300 meter. Okay, now plus sign, take plus sign. Now BC is also moving in the same direction. BC from B to C is also moving in the same direction, so it's, you can also take positive along positive x-axis, so take positive 200. But C to D, but when it moves from C to D, then it moves negative x-axis direction. Suppose this is O, and if you moving in this, then you are moving along negative x-axis, so take minus 700 here. Okay, so take, why I am taking minus 700, because initial is I am taking in this direction, which is I consider positive. So now if a person is moving in this direction, you take positive, and now if you moving in opposite to the previous motion, then you take negative sign. Okay, then you take negative sign. So your total is minus 200 meter. Minus 200 meter says that displacement is negative. Okay, displacement is negative. It means it moving opposite to the its previous motion. Previously is moving in this, then now here if he, okay, you can say that this is initial point, this is his final position, so in opposite direction take 200 meter. Okay, opposite direction to, if it is, it means negative 200. Okay, if its value is positive, then it means it's moving towards positive x-axis along 200. Okay, so in this way displacement is minus 200. Okay, displacement is minus 200. Then calculate the velocity, then calculate velocity. Okay, then calculate velocity. Velocity is displacement is 200 minus 200 meter, and time is, okay, from A to C it takes 20 plus 30, it means 50. Now C to D, time is always added. Okay, time is a scalar quantity, so it is always added. Okay, so time is here, it again take 50 seconds, it means total time is 100 seconds. You can take minus 2 meter per second. It means if a body moves, it means a body moving in opposite direction with the speed of 2 meter per second. Okay, with the speed of 2 meter per second. So in this way your velocity becomes negative. Okay, now question is that how, when a body is zero velocity, when a body has zero velocity. Okay, when a body has zero velocity, a body have zero velocity when, suppose a person start his journey, reached at point B, then reached at point C. Okay, a person start his journey from point A, after crossing B it reached at point C, it turned back. First case it's moving in this direction, but when it reached at point C, then come back. In second case it back to its previous positions. Okay, it backs to its previous position. Firstly he went to C, then C to A, then total displacement is displacement is 0, because shortest path, because this is the initial path and again it is a final path, so there is no gap between initial and final, so displacement is 0. So its displacement is a 0. Time suppose takes initially it takes 50 seconds and after that it takes 40 seconds, so total time is 90 seconds. Okay, then velocity is displacement upon time, it is 0. meter per second. 0 meter per second. So its velocity becomes 0 when displacement is 0. Okay. So in this way there are three cases. Okay. Velocity may be positive, velocity may be negative, or velocity may be 0. Now our next point is velocity of an object can be changed. When velocity of an object may be changed. When velocity of an object may be changed. Okay. Question is that velocity of an object may be changed. By, okay, our next topic is velocity of an object may be changed. It means under what condition velocity may be changed. Okay, under what condition velocity may be changed. Then first condition is that to change the velocity, okay, by changing the speed of the body, by changing the speed of an object. Okay, by changing the speed of an object, you can say that velocity may be changed when speed of an object change. Okay. The second one is and by changing the direction of motion of an object. Okay. Second one is how you can change velocity by changing the direction of an object. Then if a body changes their direction, it means velocity is changes. Okay. If a body changes its speed, then velocity is changes. If a body changes its direction, okay, but here is not velocity. Okay, here speed is constant. Okay. Third one is both means body changes its, both means change by changing speed and direction as well as direction of motion. Okay, it means by changing the speed of an object, not direction. It means what it means? It means body is moving with 5 meter per second along east. After some times you found that its velocity becomes 10 meter per second along east, but direction is not changed. Then you can say that velocity changes. Okay, velocity changes here. Okay, only changes its only by changing speed. Here it changes only by changing speed, but direction is same. In second case, a object is moving 5 meter per second east direction, then after sometimes it changes directions, but its speed is same, 5 meter per second. After that it's again changes directions, 5 meter per second, then but speed is same. Okay, then again it is said that velocity of an object changes. Okay, here body moves along straight line 5 meter, then after it turns along a straight line 5 meter per second, but direction is changed. Here direction is east, here direction south, here direction west. Okay, but so in this second case only by changing the direction, not speed. Okay, not speed. Okay, not speed in the, okay, not speed. And third one is by changing both. It means sometimes its velocity is 5 meter per second, after sometimes its velocity is 6 meter per second, and direction is also changes. Okay, direction, speed is changes, direction changes. So by both. So in this way velocity of an object changes in these three ways: only by changing the speed, only by changing the direction, or by both. Both means by magnitude of the speed change, magnitude of the velocity change, or direction. Because why we take here? Because why we take here it because it is a vector quantity. It is a vector quantity. Vector has magnitude as well as direction. Okay, as well as direction. So how a vector change? Vector change when its magnitude change, or when a direction change, or both change. Okay, so that's why velocity may be changed when magnitude means 5 meter per 5 meters, 10 meter numerical value. Okay, 10 meter per second. Okay, and direction is east west. Okay, so in this way, if one change, then velocity change. If this change, then again velocity change. But if both change, then again velocity change. So in this way, these are some important points which is very, very important to understand velocity. Okay, now our next point is types of velocity. Okay, types of velocity. So first type is uniform velocity. Okay, uniform velocity or constant velocity. Second, it is similar to our types of speed. It is similar to types of speed. Same type we studied in case of velocity, because we know that speed has 4 types: uniform speed, non-uniform speed, average speed, as well as we study about the term instantaneous speed. Same things we study about the velocity. In first we study about uniform velocity, second one is non-uniform velocity, third one is average velocity, and then after we study about instantaneous velocity. So one by one we study about these points. So first of all, our first point is uniform. The another name of uniform is constant. Constant means fixed. Okay, simply if I am saying, then it means object having the same speed and same direction. Okay, if object is moving with 5 meter per second, object moving with 5 meter per second. Okay, and direction is also not change. Okay, then direction is also not change. And but when it happens when object covers equal displacement. Suppose a object having position is at A is 5 meter and time takes 1 second. Okay, after 1 second, again it means after 2 seconds its position is at 10 meter. After 3 seconds its position is 15 meter. And at point C, then you found that it's, suppose this is reference point, we observe that we know about the reference point. Okay, so object covers first 5 meter displacement in 1 second, then what its speed, displacement upon time, then it's equal to velocity is equal to 5 meter per second along east. Okay, long east. So this is its velocity 5 meter per second. Then again it's 5 to 10, it means displacement is again 5 meter and time is 1 second. Okay, it means again its velocity becomes 5 meter per second. And after 3 seconds it's covered 15 meters. So displacement is 15 minus 10, 5 meter, and time is 3 minus 2, 1 meter. So time interval is 1 second and displacement is 5 meter. So when you get the velocity, then you get again 5 meter per second. So when a body is said to be uniform velocity or constant velocity or fixed velocity, when body covers equal displacement in equal interval of time. Okay, you tell me direction is changed in this case? No. So you also write about it. Equal displacement in equal interval of time without changing the direction of motion. Okay, without changing the direction of motion. So when a body is said to be uniform, when a body moving with same speed, same velocity in same direction, when a body moving with same speed in same direction, then it is said to be uniform velocity. Okay, but in this case direction not change with time. Okay, so when a body covers equal displacement in equal interval of time, then it is said to be uniform velocity. Okay, and what is the case in case of non-uniform? In case of non-uniform, second type is non-uniform motion. The other name is, tell me, same as which is in speed. The other name is variable velocity. Okay, that another name is variable velocity. Okay, when a body is said to be non-uniform velocity or variable velocity, when a body covers unequal displacement in equal interval of time, or vice versa. You can write it vice versa. Okay, vice versa. It means in first case body covers 5 meter distance in 1 second, but in second case it reached at point 50 meter. Okay, but in case of B it covers 50 meter distance in 1 second, then at 2 seconds its position is 50 meter, and after 3 seconds its position is 150 meter. Okay, its position is 150 meter. Then calculate its speed, its velocity. Okay, because it is a straight line motion, so it is also displacement. So displacement is 5 meter, time is 1 second, its value is 5 meter per second along east. Now, but in case of second case, you found that distance is here, position is 5 meter, and after 1 second its position is 50. It means how much displacement it cover in 1 second? In 1 second it covers displacement 45. So velocity becomes 45 meter per second. Okay, and here is again in 1 second it covers 150. 50 to 150, it means 100 meter. Okay, when you calculate the speed, then you found that 100 meter per second along east. It means that firstly body covers 5 meter per second along east direction. After that body gains speed, again velocity, and it becomes 45 meter per second. What happened? Magnitude is change. Okay, magnitude is change, means velocity change. Variable means changed velocity. Variables means changed velocity. It means in unequal covers unequal displacement. If a body covers unequal, in first case is cover 1 second 5 meter, in 1 second 45 meter, in 1 second 100 meter. Then body covers unequal displacement in equal interval of 1 second 1 second 1 second. Okay, in equal interval of time body covers unequal displacement. So body is said to be non-uniform velocity. Body is said to be non-uniform velocity. Non-uniform velocity means sometimes velocity is 5 meters, sometimes 10, it's 5. It means non-uniform velocity. Velocity is varying. Okay, if body is same, it means 5 meter, 5 meter, 5 meter. Every point its velocity is 5 meter, then body is said to be uniform. Okay, so this is the way to understand uniform velocity and non-uniform velocity. Next one is average velocity. What it means? Average velocity means sometimes you found that, okay, you are, suppose a person is moving from A to B, then you found that here speed is, here velocity is 6 meter per second along east. Okay, here speed is changed you says that 10 meter per second. Here speed is, here speed when you moving, then here speed is 2 meter per second, and finally you speed gain and you raise, and your speed becomes 20 meter per second. Then you found that when you moving from A to B, you have different velocity. Okay, then you found that you have different velocity. So what is the average velocity? Average velocity, how you define average velocity? It is similar to the average speed. Okay, but replace distance divided average speed is equal to distance, ratio of distance upon time, total distance upon total time. So similarly you can define average velocity as, similarly you can define average velocity as the average velocity of an object may be defined as the ratio of total displacement to the total time taken, to the total time taken. That is average velocity is equal to the ratio of total displacement upon total time taken. Okay, total displacement in short form, how you can write it? Total average speed is average velocity. So average velocity is v plus a arrow, and average, write average, which is equal to total displacement. Suppose that the first displacement is s1, then second displacement is s2, and so on, third displacement, fourth displacement. Then you add all the displacement and divided it with time, t1 plus t2 plus t3 plus t4. So this becomes the average. So this is the formula of average velocity or average time. Okay, if you want to take an example, then you take as, suppose a object covers first 5 meter displacement. Okay, then after that it covers 10 meter displacement, and finally it covers 20 meter displacement. Okay, in first displacement 5 meter displacement cover in 2 seconds. Okay, then after that 10 meter displacement cover in 1 second, and after that it covers in, suppose that it is again takes 2 seconds. Then calculate the average speed. Okay, then average speed, here if you found that here its velocity is 2.5 meter per second. It means its velocity is here, its velocity is 2.5 meter per second. At in this case its velocity after some times, after 1 second, its velocity becomes 10 meter per second, 10 divided by 1. Okay, 10 meter per second, its velocity is 10 meter per second, and after 2 seconds its velocity becomes 20 divided by 10, it means 2, it means 10 meter per second. Again its velocity is 10 meter per second. It means you found that it has different velocity. This is different velocity, this is different. Okay, so this is known as, at every point it has some different velocity. Okay, or maybe same, in this case it is same, but previously it is different. Okay, so it is a variable velocity, non-uniform velocity. Okay, so then you found how you can calculate the average speed. No take add plus divide, no, this is not good. Okay, the formula, follow the formula. The total displacement is average velocity is equal to total displacement. Total displacement is 5 meter plus 10 meter, 15 plus 20, it means 35 meter. Total displacement is 35 meter and total time is 2 plus 1 plus 2, it means 5 seconds. So you get 7 meter per second. Okay, if you want to show direction, then takes its direction is along east, and by the way it is not given, then it is positive. Positive means along x-axis. Okay, along x-axis. So this is the way to calculate the average velocity. Okay, this is the way to calculate average velocity. Okay, so average velocity means a person is moving at different speed, but how much distance is covered? Suppose s distance it covers, and how much time it takes? It takes t times. Then what is its average speed? Average velocity means, then what is its average velocity? Average velocity means a uniform velocity with which it moves with to cover same distance in same time. Okay, what is its uniform velocity? It moving with different velocity, but what is the significance of average velocity? Average velocity means what is its average uniform speed with which it moves to cover the same distance in same time. Okay, in cricket we use run rate. Okay, run rate or strike rate. Okay, run rate in which 20 overs, suppose in case of cricket match, in 20 overs its average run is 6. Then what it means? It means, it does not mean that in every over it gets 6 run. It may be that sometimes it gets 20, sometimes maybe 5, sometimes maybe 1, sometimes maybe 6. Okay, in different over we get in different order in over run is different, but average gives a idea that with what run you get in every over. Okay, similarly average speed gives you idea that if what speed it moves to cover the same distance in same time. Okay, if it moves with 7 meter in every 1 second, then it covers the same distance in same time. Okay, so it gives a kind of uniform. We get a average speed give a information a non-uniform to uniform speed. Okay, this is non-uniform. This is non-uniform speed. This is non-uniform speed. This is non-uniform speed. But if we get average, then it gives a uniform speed. Okay. Okay. So gives an idea what is its uniform speed. Okay. So this is the average speed. Okay. Next, the velocity of an object at any instant. The velocity of an object. The velocity of an object at any instant. At any instant. Instant means movement. At any instant during its motion, at any instant during its motion is called instantaneous velocity. Its symbol is, you can write, gives the symbol V is instantaneous. Okay, V instantaneous. Okay, V instantaneous. Okay, what it means? It means that suppose a person is moving, a body is moving, here its speed is 2 meter per second at point A. At point B is its speed is 50 meter per second. At point C is its velocity is 5 meter per second. Similarly, at different time, different point, it has different speed. But as it's moving with different speeds, suppose its velocity is 25, 2, 3, 4, 50. Okay, it means it has different speed. But if I'm asking about at this point, what is the speed of the body at right time, at this moment, then that speed is known as instantaneous speed. It has different speed, no doubt, but if I'm asking that what is its speed at point B, not tell me about the C point, not tell me about the A point, not tell me at this point, tell me that what is at this point, what is the speed of this, then this speed is known as instantaneous speed, at that instant, at the same time, at right time. Okay, the speed of an object, the velocity of an object at that instant is known as instantaneous velocity. The velocity of an object at any instant during its motion, its body is moving, and I am asking at point B that what is its speed. You says that sir it is 50 meters, then that is instantaneous speed. You are moving and it reaches at point B, C, and crosses the C, then I am asking what is speed, what is its speed at C. It says 5 meters. That speed is velocity is known as instantaneous velocity. If I am asking about the speed, then it is instantaneous speed. If I am asking about the velocity, then it is known as instantaneous velocity. Okay, so this is the topic of instantaneous velocity. So you study about in this video about velocity. Okay.